Well, I see we're a minute or so into the top of the hour, so we should go ahead and kick off the real topic here for today's webinar, which is talking about high density Wi-Fi in education. And we brought on a few special guests to help us with that, and I'm pretty excited about this one. So yeah, let's jump into this here. So who do we have on the call? We've got Joel Crane. Joel, you want to introduce yourself quick?
Yeah, sure. I'm Joel. I am the technical trainer here at Ekahau. And I'm probably just going to hang out in the chat on this one and let you guys do all the smart talking and stuff. I'll just probably hang out in the back.
Right on. Well, I'm Jerry Ola. I'm one of the product managers here at Ekahau. Usually this is kind of the Joel and Jerry show, but every once in a while we get to one of these topics that, or I should say many of these topics that Joel and I aren't the subject matter experts on. And we, reach out through the community to find some people that are a little more well-versed. And actually, Nathan, been following him on Twitter for quite a while. He had tweeted several months back about a really awesome project that he had been working on at the university he's at, and got to chatting with him about that and said, hey, we're working on doing a webinar coming up here about Wi-Fi in education. And just the stars aligned and made it work. Even a little crazy time zone challenges on Nathan's side. But Nathan, yeah, you want to introduce yourself and maybe give us a little insights into that?
Yeah. Thanks for having me, guys. Firstly, on the webinar, much appreciated. It's currently 4:03 a.m., so if I sound a bit croaky on it, please do mind. I'm a senior network engineer at Monash University. I'm 25 years old and Ekahau Master number 22. I retain a CCNP wireless, and hopefully I can get around to studying for my CWNE with all these crazy projects we got going on. I've worked in the education sector for around 5 years, and it's been quite an interesting journey, as anyone would. And we currently support up to 80,000 clients. On an average day, we see around 45 to 50,000 clients associated to our network. We have multiple campuses that span across different countries, and we're currently sitting at, I think, that count is quite wrong. I think we're sitting at around 7,821 access points at the moment. So wow. Quite a large network. So it's one of the biggest wireless deployments in the Southern Hemisphere at Monash University in Melbourne.
Yeah, and through that particular project that you had mentioned on Twitter, we were chatting about it, and you had mentioned that because of the complexities of the project and some of the unique challenges and stuff that you were dealing with, especially with using Cisco equipment, you were able to get that bubbled up to Mr. Florwick here, and that's where he comes into play in this. Jim, you want to introduce yourself and talk maybe a little bit about that?
Yeah, sure. I'm a senior technical marketing engineer, which that's changed organizationally, but basically I get to be the interface between customers and engineers. I've been doing this at Cisco now for about 11 years. I've been in Wi-Fi for about 15 years. Came to Cisco through a little company called Cognio that became Clean Air, and somehow or another they felt that I belonged at the physical spectrum edge, and I've been very fortunate to delve into all things physical and staying up to date on RRM and how to use that best to solve your problems. So the journey with Ekahau, I am an Ekahau Master. I don't know my number right off the bat, but it's low 2 digits. I think it's 17. Ekahau is probably the beginning to everything I do. So I was excited to hear or get the tweet from Nathan. Although, it's 4:03 a.m. there right now, I tend to get his tweets very late at night here.
Sorry, Jim.
Oh, it's okay, man.
Right on. Very cool. Well, thanks, guys, for coming on and helping us with this topic. I think this is going to be really valuable to our customers. And actually, I think what I will do is turn the screen share here over to Nathan. If you want to share your screen, and we can start there, and you can kind of walk us through this project a bit, and just in general education and some of the unique challenges that you've dealt with over the years working with this stuff.
Yeah, definitely. Thanks, Jerry. Yeah, so this is at one of our campuses. I'll just give you a little bit of background about Monash University as a campus. Quite innovative. We're moving obviously, into that new digital age where everything's about innovation. And this is one of our buildings which we recently built, I think last year, the Learning and Teaching building. So it's a $225 million project. Obviously, it's state-of-the-art technology to obviously help the students, um, you know, get a better environment and obviously learn well and different ways of learning and education. So yeah, it's quite an interesting looking building and really, really good, design and architecture.
That's beautiful.
Yeah, it's really futuristic.
What
Acts as
could
a
go
Faraday
wrong with
cage
RF?
too.
Looks very RF friendly.
It
Yes,
does
yes,
indeed. On a reflective surface in sight.
yes. We've had our issues with that. So we'll move on to the next slide. So look, I just want to bring up the first, top 8 concerns which we see in higher education. I think this is, very, very important in a way where we're looking at, from starting from 1 all the way up to 8, well-defined operational policies. It's quite a very interesting topic in a way where, we have to have the correct policies defined and correct standards in place for us to accomplish our goals. And we get into the requests of BYOD and IoT all the time. The other departments come to us and say, we've got this crazy IoT device, we want to get it on the network, just make it happen. And sometimes where you have to discuss with the customers, find leverage with the customers and understand, how to go about it. Where we move into not all buildings are created equally, this is something that's quite big too, where, I hear from a lot of the engineers, I've done a design in one building, let's just do the same thing in the other. And it's not the case, where engineers don't bother attending site and, just quickly do a predictive design just based on a floor plan. And there's always hidden things, especially when you're dealing with, ancient buildings. Not so much at our university, but other universities which I've worked at, where you're dealing with 1800 buildings, and there's lead-lined walls or there's thick concrete walls which you can't actually see on a CAD map. Budget cycles is a very big thing also for us, where nearly every year, every 3 years, we're having to replace hardware and get to the latest and greatest because the market is moving at such a fast pace. So we're constantly in talks with our Cisco to obviously expand our environment and look at the latest technology. Number 5 always brings a bit of laughter to me, because we had this issue the other day where there was an event that was held on campus where we didn't actually know it was a high density area until we actually did some monitoring around it, where we had 4 access points servicing a large event which took place, was with over 1,000 people. So it obviously impacted our environment quite heavily. So always get to know your spaces and survey every area and understand where the clients, do a little bit of analytics and understand where the clients are looking to be and how you can provide better coverage to them. Compliance, have compliance within your organisation and stick to the regulations which are stated. Obviously understand the legalities around that too, especially with a higher education environment where, reputation is everything. Always be good with your managers. Within the university environment, people state that there's a lot of politics around there, so you got to learn how to deal with everyone. Not everyone agrees to what you have to say, so just state your case. And at the end of the day, it is a business, so we've got to look at what's best for the university environment, obviously, and for the students who are there to support and and provide good workmanship too.
Yeah, and these top 8 concerns, they actually stem from, if you guys are familiar, anybody on the attendees there are familiar with Lee Badman. I believe he helped us with putting that infographic together. I put a link to that in chat if you want the full infographic. But in chatting with Nathan about this, said, do these align with some of the challenges that you've and some of the concerns and stuff that you deal with. And I think they all, I think you said, resonated pretty well with the stuff you're seeing daily. Yeah. So yeah,
Yeah.
Lee was on the right track with those. So yeah, thanks Lee for helping us put those together, and Nathan for confirming that we are looking at the right concerns.
Yeah, thanks so much, Lee. It definitely is spot on. I was actually laughing when I saw it, so thank you very much. So here comes the project. Basically, I got a request where we need exams over Wi-Fi. As you can see, that was my face, the photo below, when they told me in the meeting where, we need this to work, we need 100% uptime, we need good speed. It was just crazy at first hearing about it. So I said to him, well, why do we need to achieve this? And they said, well, look, we want to redevelop the way students undertake exams, the way students think, a better experience and a better environment. We want a completely new way of thinking and be innovative with everything we do in Monash culture and move into that digital age. So it's easier to expand with a logical exam system. We can expand on the new learning processes and build from there, and obviously help a lot of students too with disability impairment, which is a big thing for for why we do this and why we're engineers. We want to achieve. So my basically what I stated was, why change something that is not broken? Paper-based exams have been there for 100 years. Why change it now? Yeah. And then I saw this.
Well, at least there was no pressure, right?
not that much pressure. There'll be pitchforks on me. So I saw the environmental impacts that it had. Monash as a university issues over 360,000 exams a year, which was quite astonishing, a lot more than what I thought. It's equal to 8.5 million sheets of A4 paper, which equals to over 1,000 trees. So there is definitely a significant impact on the environment. So after seeing this, and obviously the pros to having logical exams, I said, let's undertake it. Let's see what we can do. Let's work as a team, and we'll achieve the result.
That's a pretty cool motivating factor when you put things into that kind of perspective. It's not just about convenience anymore. There's a lot of other implications that you can impact.
Yeah, and as what we saw, from the Cisco Live and other universities, and our university, where everything's looking at smart city, we're looking at being sustainable and having renewable energy in the future. So this thing here is very big impact for universities at the moment, especially not only in Melbourne but across the world.
That's like a small or a pretty good sized forest.
Thanks. So everyone's got a way of undertaking a project. One of the ways that I have learned with a lot of the projects which I've worked on, I've got normally 4 phases, obviously with the requirements gathering at the start, where we'll start to talk to the client or the department. We'll understand what they want to achieve, and we'll collaborate together. So we'll have to, obviously, if we don't agree to it, we'll come to a compromise, or we'll have talks and discussions around it and how we can achieve. But one of the things that we try to stand by is achieve everything. So I know it's quite difficult to say that as wireless engineers, but that's the age that we're moving into. So we have 4 main phases of the project, which are planning, design, implementation, and support. I'll start with the first the first part, which is requirements gathering phase and what's involved with that.
Real quick, Nathan, I forgot to mention in the beginning of the call here, the housekeeping items that we usually always bring up is we've got the Q&A panel. So as Nathan's going through this stuff, if you do have questions that come to mind, you want him to dive in deeper on any of these, especially as he's going through these phases, feel free to open up that Q&A panel, put in the question there. I did make sure to enable the upvoting so you can actually see the questions that are being asked, and you can even thumbs up them if you have the same question. That way we make sure those get bubbled up to the top and get those addressed when we get to the Q&A section at the end.
Yeah, no problem. I'm happy to answer all questions. So this was the site as a stand. It was basically at one of our sports stadiums, our largest sports stadium on campus, and found that it was a good place to hold the exams. So as you can see, there are all the desks lined up, and it was quite mind blowing to see that a sports stadium is now our exam hall.
Talk about a multi-purpose room.
Yeah, this blew me back a bit when I saw it. I said, "Oh, okay, now we really have to get to work on this, and let's see what we can do." So we initiated the requirements gathering, where we had the initial site walkthrough with the stakeholders and the department that was undertaking this, project. And I said, let's all meet on site. We've got managers, project managers, engineers, network engineers, cablers. Well, let's find out, what everyone thinks and how we can achieve and start, brainstorming. So one of the things that I bring to a project, it's generally, it's only my, opinion, but this is what I feel that's necessary when going to a project, is where we have, A3 floor plans. Always look to get the most updated floor plans, whether it's a CAD file, a DWG file, or a fire escape plan. I ask the client and see what you can get, and just keep pushing for the most up-to-date floor plans, because it will make our lives as engineers easier, and Ekahau will take care of it. So I also bring coloured pens where I can, as I'm walking around on site, I'll start marking in walls. If I see that there's a concrete wall, I'll mark it in a certain colour. So when I get back to my desk, I can visually see what's currently there, and then look further where we come to the design phase. So yeah, bring a laser measure. Fantastic tool to have, especially on a large site like this, where we're not walking around with the measuring tapes. We can quickly get the accurate measurement, and we can throw it into Ekahau and make sure we scale our map correctly to get the correct results. And I'll obviously put the map on Ekahau and start using picture notes, take a lot of photos around site as we're looking to, walk around and understand the correct parts to the site, and what are the obstructions and what we can see visually. And I'll go around and I'll scope around what existing neighbouring access points are currently on site. And always remember to ask questions. That's one thing I can't stress enough. Don't be afraid to ask a question to the client or the stakeholder, and get the answer that you need quickly. So we move into phase one, basically planning. So as you can see, that was we had Monash University laptops, which are currently there on the picture on the right, where we're starting to look at how they interact with each other and the application behind it, and all the wireless driver settings and chipset settings. So it was quite a 657 laptops, which we went through, and it was quite an interesting topic and quite an interesting day. So the first question I'll basically ask, the client or the department that are undertaking this project is application used. Well, what are we trying to achieve out of the application? Will it be YouTube video 1080p? Are we looking to just run certain applications that are on there, which will be constantly streaming, so we can plan correctly for this? What's the total client count that is expected? The expected device type, is it only one device that will be used during the exam, or is it going to be multiple devices that are used? Petitions or obstructions, which sometimes come up within our exams or exam halls, where they'll put up a petition within a wall. So on the map, you look like you've got an open area, and you'll get there and there's 8 petitions, all with metal sheeting across it. Aesthetic and mounting concerns, where we want to be able to, obviously visually for it to look good, as we're a university and we're representing good culture and good engineering. And if there's any mounting concerns where we're not allowed to mount in certain areas, whether it be asbestos, whether it be obstructions or OHS. And security and physical, well, security being physical and both logical. So the physical environment, is the environment locked down? Can we actually get on site in certain areas or certain times of the day? And logical security, how safe is it to the university, and is there any security impacts, both from a network standpoint and obviously RF standpoint?
I'm curious with that. So this is all still part of the design phase. So at this point, would you have, you mentioned before walking around taking photos with, and putting that into the project file. Is that right? And the first, the gathering of requirements, right? So yeah, this phase, when it comes to your planning and your predictive design and modeling, have you started on any of that yet, or is this still pre doing any of that?
Still pre, just gathering all basically gathering the requirements and planning is sort of the same phase, where we're still just trying to suss out what exactly is going on and what what we're up for. So the design phase is when we'll start, using the modeling and thinking about how we're going to achieve, where we're going to place our access points and how we're going to achieve it, what type of access points we're going to use, and what we have to, basically achieve at the end and get the correct result which we're needing from our discussions with the client. So we move into the design phase 2. Patch antenna versus an omnidirectional antenna for a high density, and I'm sure Jim can elaborate on this, for a high density environment, patch antenna or directional antenna is much more preferred, but there's obviously constraints around it in some cases, this being one of the cases that we had, where we're dealing with a stadium floor, and we're having to beam down the signal down to the clients, and which we tested, and we saw that we're seeing reflections coming from the stadium floor, the basketball court. So I reached out to Jim and said, we've seen this weird coverage pattern. Why is this occurring? And we had a proper look and realised that the signal was just bouncing back off the floor. So Jim, if you want to elaborate on that.
Well, that reflection problem gets a lot better once you coat the floor with people, or attenuators, as we like to think of them, and directional nature of the antennas. Not just directional, it's a really good sharp edge on it, because your biggest problem in there is going to be isolating channels. And if you can isolate the cell, you're going to get the full bandwidth.
Yeah, definitely. So we obviously had mounting constraints too, and a lot of OH&S has it around it. We've got 650 students sitting in a hall. How can we go about mounting access points on the ceilings? We've got 20 meter plus ceilings. It wasn't well liked in a way where we were allowed to mount on the ceiling, so that was quite squashed straight away. So we had to come up with a new idea, and considering the amount of clients we had and the density that we had in a room at the one time, whether we can provide a proper cell edge to them clients and provide proper coverage. Data rates, Jim, if you want to talk about the data rates and the transmit power, which is what we're discussing.
Oh, Jim,
well, hang on. Let me work with the mute button here.
You got it.
Data rates are another way to make that cell smaller, because your problem with capacity is everybody's sharing that cell, right? So lowering the minimum data rate or raising the minimum data rate, particularly the denser you get, physically makes that cell smaller. It also defines what SNR the client has to be at through virtue of the data rate to access or get on that AP and authenticate. So it has twofold. It makes the cell smaller so that you get better user to bandwidth separation. It also spreads the users out, because there's not a lot of reason to roam inside of a big, large reflective environment where you shoved a lot of APs.
Yeah. With the transmit power too, which is what we had a discussion about. How we'll see. Yeah, very interesting
that was
topic.
The second part. That room, once you put the attenuators on the floor, is going to be a lot less reactive. So you definitely want to have the transmit power up and not rely on automatic transmit power. So at least set a minimum bound that puts the transmit power where you're going to need it once you have all the density of the bodies in there.
Yeah, so moving along with the wireless chipset and drivers, we saw that we were quite lucky, which we're using the same sort of model of laptop which we're providing to the students, where we had a script which we could update all the drivers at the one time, being 650 plus laptops. So we always look to, download the latest and best drivers from Intel and ensure that the bugs are fixed, that we weren't seeing any issues going forward. Co-channel interference and signal to noise ratio was a big thing on the floor, where we got such a high density And we've got so many clients talking at the one time where we saw a lot of the noise floor rise and co-channel interference between the access points. Being such a large area, we were relying purely on attenuation within this area, or else it was not possible to achieve the result we did. And secondary coverage, that if there was an outage for any reason, we could obviously ensure that there was proper coverage within that area. So these are some of the tools that I use when looking to initiate the design phase. Obviously, the Ekahau Sidekick has helped us immensely. We use 2 or 3 sidekicks between the engineers, and it's easy for the juniors to get out on site and understand how it all works. So it's a really good product, and it works well in determining the correct measurements. I do have a car jump starter battery pack, which obviously feeds into a PoE plus injector, which we can power the access point, and we get around 2 to 6 hours worth of site surveying with that method. Some of the tests which we initiate, like throughput tests and download upload tests, are from obviously Ookla, which is Ekahau's parent company, speedtest.net, and one of the ones that I generally use is testmy.net, which is like an open source testing party, which provides obviously non-biased results and fantastic, information for the engineers to visualize. One of the things that I found out that, being on site and having to angle antennas back and forth, we use a program called Angle Pro. I think it's generally found on iPhones, and Google AR Measure App, which we can determine where we have an access point antenna where we can angle down into the correct location and be able to see what type of degrees. I've got actually a photo on the right there we're getting at. So if we want neg 45 degree tilt, we'll put the iPhone right onto the antenna and slowly move it down, and then we can get the correct neg 45.
Yeah, that's cool. I haven't seen that one before. I just downloaded that right now.
Oh, it's fantastic, especially when using directional and patch antennas. We use it all the time. Where I'll tell the guys, we need neg 50 tilt. I want to see what neg 50 looks like, and then basically we'll get the iPhone, just pop it down, and we'll have 50 degrees perfectly set. Blake Crone's website. If Blake's listening, thanks for that. RSSI Compared, it's a fantastic website to jump on, just to determine the offsets between the Sidekick and other client devices. So we use this quite heavily to visualize what the client is actually seeing, not so much what the Sidekick is seeing. Wi-Fi Analyzer, fantastic Android app, and Cisco SE Connect mode on access points, which helps us to obviously look at what's happening in the RF space during the exam, where we can't actually get on site and be able to do our own testing. And another good tip is Stats for Nerds, where we can visualize, if we're running HD videos or testing HD videos, we can see what the current stats are and the compression rate, whether it be H.265, and whether we can stress test the environment. These are some of the download and uploads from testmy.net, which it'll send you a large amount of data, and it will download and send you another amount of data. It'll basically stress in your system, and will provide you with some nice charts. This is just a little example of Blake Crone's website, RSSI Compared, where you can see the difference between the Sidekick versus all laptops. And you can dig down, a lot of the engineers, which I appreciate from the community, have actually taken the time out to test in their own environments what they're seeing on their client devices, and obviously input onto this website, which helps everyone across the world, including myself. So thank you very much to the community for that.
Yeah, and it'd be great to get more, more measurements, the better, right? The more measurements we can get from the more devices, the better the results are going to be, or more accurate they're going to be. But yeah, this is a great way to compare kind of a summary of all of a specific category of devices against a certain measurement device that you're using. In this case, this is an interesting comparison between the Sidekick and your laptops, and now you have a good differentiator to show.
Yeah, looking at the median of the differentiator, where we've got neg 7 offset on a 5 gig device. So it's quite interesting to see, and definitely useful to use on site.
Yeah, it's
So
really
the first,
interesting even to compare like laptops versus smartphones or tablets, and like how big of ranges there can be between those categories.
yeah, yeah, always compare before you add more access points. Always compare. So moving on to the proposed design, patch antennas. I'm a massive fan of the Cisco 2566 P4W, which you see on the right here, and the way we use it across campus for a lot of the high density deployments which we do. I reached out to Jim purely for this use case, where gathering some more thoughts and his expertise on how we can achieve this result.
We use those antennas extensively.
Yeah. Cisco Live Melbourne actually just a couple of days back, or currently they still use them. So they've got a really good deployment across the board using the 2566. So it's a really, really good antenna to use. One of the constraints which we had, especially from a lot of the pushback from our HNS officers, were tripods within the small sections, or where the adjudicators could actually walk during the exam. So it was a temporary. So this was a complete temporary solution which we needed, and we weren't able to accomplish it with the correct tripods. We found also that the beam width was too wide to cover a certain area. Attenuation, it's very difficult to site survey where you're relying on attenuation and you're relying on your expertise, and you can't obviously site survey during 650 clients being undertaking an exam. So it's a very, very difficult initiative to undertake. And obviously the reflections which we saw from the basketball court, which, as what Jim said, will be squashed due to the bodies within the way of the signal. So this was the proposed design which we had for the 3802E with the 2566 patch. We can see that the design, the tripods would be sitting within the way if we were trying to get the correct density for that environment. So we found that it wasn't a reliable solution, both for the safety of students and obviously for the density which we needed and the throughput which we needed to achieve. These were some of the pictures on site of just us doing some testing. Obviously the different angles which we use and the different sort of tripods and methods which we use. And that you can see on the right there is actually a speaker mount. One of the guys came up from a local store. In Australia we call it Bunnings, and it basically used a speaker mount which works perfectly with the Cisco patch antennas, where you can angle all the way down and all the way up. So it's a fantastic idea to use. So this is where I once again reached out to Jim and I said, look, I'm a massive fan of directional/patch antennas. I can't achieve it. Is there any way possible we can use omnidirectional in a room that's this dense? How can we go about it? Do we go above? Do we go below? And Jim came back with an idea. Well, let's go under the seats, or let's go just in between the seats and the aisles. So Jim, if you want to elaborate.
Jim's trying to find he's trying to find the unmute button.
The unmute button, and I was answering a question. I'm sorry. I should do one or the other.
All good. I'll continue on. All good.
Yeah, no. So, I presume you were talking about the design and under desk strategy.
Yeah, exactly.
Yeah, it's not optimal. We've moved away from it, but when you talk 20-meter ceilings, that's even less optimal and more expensive unless you're going to make a permanent installation. So you can definitely do this under desk. Just keep in mind that with the APs being able to see one another better on the floor, that's a challenge that you have to isolate. You're also going to get ducting between those legs and desks. So it just makes it a little more critical to tune. And then the secondary thing is you won't get as much dynamic range because you're definitely going to get a little more interference.
Yeah, and that was one of the issues which we had to deal with, adjacent channel interference and co-channel interference. So this is just a predictive design which we came up with, which obviously EchoHow allowed us to achieve, close to realistic results. So where we measured, where we had every 1 meter was 5 dBm loss between a human body. So we input that into Ekahau, and then we use a predictive modeling to determine what coverage and what we're expecting to see on the floor. So we have an SE. We also, if you can see within the certain sections where we've got 4 SE Spectrum Expert Connect or SE Connect mode access points, which we're using to obviously look at the RF within that area during the exam when the exam is being held. So I'll now take away the screen and go into a demo of the 3802i Predictive, which we used. Some of the tips which we can achieve to use. So we can see that the coverage pattern was quite nice. We're covering a certain area. Obviously, with the predictive modeling, we're not looking at a 100% result, but we're looking at some sort of guarantee, which we can actually propose and give back in a proposal design or design document to our stakeholders. So you can see here where you've got cool things where I've used that offset. If you hold down the control button on a Windows laptop and click the legend where we can use view as, and we can add our different type of offsets here. So we were using a MacBook Pro, which we had an offset at -5.
And are those offsets that you measured, or did you get those from the RSSI Compared website?
Yeah, generally the offsets that we've measured too, but generally we've got them from the RSSI Compared website, where we've looked at generic laptops and what we're seeing on the floor, which we've done our own testing on. So it helps us to visualize what the client's actually seeing, and a lot more realistic, where we and obviously money saving too, cost saving, where we're not adding excruciatingly high amount of access points or take away coverage from the client. So one of the other things that I use was if we hold down the control button and hit options, we can look at the visualization height, where we're visualizing the client at a certain level. Visualizing the signal at a certain level. And obviously we've got our primary and secondary coverage, which we're looking to achieve full redundancy across the board. So for this design, we were using FRA and dual 5 gig, where I had a discussion with Jim and said, look, 2.4, it's just going to kill us on the floor. Coach, there's so much code channel interference. How can we go about it? So we ended up using the Cisco 3802i, and went ahead and said, like, this is what we need to do.
And I remember talking with you before. I'm guessing you'll get back to it in the slides here. Actually, I think it's your next slide, so I won't steal your thunder.
That's okay. Go ahead, Jerry.
No, I was just going to say, you mentioned that the 2.4 issue and co-channel interference, is going to kill you. But I think you also mentioned you found some other interferers on the 2.4 side as well that, made it a major case as well to move to something like a dual 5 deployment. Yeah.
As we initiate the design phase, we'll site survey before we do anything of the current site, and we'll see the existing access points and that are around that site. So, we did see a rogue access point that was on 2.4 that was broadcasting 40 megahertz, and we did see a video camera that was also put in there by another department, which just basically put it in there with no request, and you could see it was smashing.
That'll wreck your whole day.
Yeah, so it was terrible.
So you just had to use 2 channels and get that done, huh?
Right.
It was a bad day. So this is where I reached out to Jim and said, we're going dual 5.
Yeah, quick question for you, Nathan. What do you find? What is your experience on your campus for 5 gigahertz capable clients versus 2.4 gigahertz? Do you have a lot of 2.4 only?
Look, we still do, and we as a university environment, when you're dealing with 80,000 clients, 45 to 50,000 connected on an average day, we will see a high amount of 2.4 still, or legacy, but obviously 5 gig taking the reign as we move into the new age of 802.11ax and 802.11ac being previously passed. We're still seeing some sort of clients on 2.4, but generically it's mainly 5 gigahertz.
The clients on 2.4, are they only 2.4 capable, or are they just clients that wandered into 2.4?
Clients that have wandered into 2.4, but we use obviously RRM and band steering to achieve, pushing clients onto the 5 gig. So we really want to enforce, 5 gig. If it was up to me, I'd turn off 2.4, but I'd probably lose my job.
Right.
Invite me down.
You can take care of them. So we move into phase 3, which is the implementation. I can't stress this enough to engineers, and I see it. I've seen it a few times where, they'll let the cablers just do their thing. They'll let the electricians just do their thing. I'm pedantic when it comes to attending on site. When the data cablers / electricians are about to install, be on site. Watch them, understand what they're going to do, build a good relationship with them. At the end of the day, they're helping you do your job. You're helping them do their job. So just build a proper relationship with them, and if there's compromise, attend there and talk with them about it. Ensure access points are placed in the correct locations. That's one of the big things. We've seen at other sites where it's a give or take 5 meters, and we're like, nah, it's 1 meter give or take, if that. Survey, initiate your passive site surveys, tweak, resurvey, keep tweaking, and Jim can lead on to this topic where where we talk more about RRM in that space with the FRA settings.
Yes, it worked, didn't it?
It did.
I think your question to me was, you're going dual 5 gigahertz. Should I just put them all on dual 5 gigahertz? Well, then you run into channel problems because you're going to exhaust it pretty quickly. So getting an opinion with FRA, even if that's your intent to manually set things, getting that opinion really gives you a good idea of what your over-the-air characteristics are and what it thinks. But I found it to be very accurate.
Yeah, definitely. We saw some access points obviously flip to monitor mode and obviously mitigate the interference which we're seeing on the floor. And with the RRM, the dynamic channel assignment was fantastic in a way of trying to mitigate the co-channel interference right next to each other, and transmit power control also kicked in. One thing to watch out for in this sort of environment where we're relying on 100% reliability is if we're using DFS channels. That's a big thing, because we're actually under a flight path, but it doesn't actually undertake under this campus, which we looked at beforehand, and we actually logged into the Cisco access points to determine whether we're seeing any DFS events on our access points within that vicinity. There's something to look out for. The higher data rates, I think, will flip in back between 24 meg, 36 meg mandatory, and this was another discussion which Jim can probably lead on to.
It's always the question, 24 or 36. I think, ultimately, did you go with 36 megabits per second?
I think we went with 36 because we just saw there was so much coverage in the area.
Yeah, for the ones on the floor, definitely. They're definitely close enough. Once you start to get the high altitude with the, like stadium antenna models, then it's a question you need to take a look at SNR, and previous experience in that space is definitely required, because if you go too high, you'll end up with coverage holes. So generally best to start at 24, move it up to 36 once you've had that space built and verify that it's okay.
Yeah. So one of the things we tried to test was gathering staff members to test the attenuation and initiate a site survey, which was quite a difficult task. There was no way we were going to get 650 staff members. So my manager made it happen, and I thank him, take my hat off for it, where we were able to get 50 staff members to work from the exam hall and do a quick site survey to test in a vicinity.
Did you buy
pizza? Yes, we did.
There's pizza. There's pizza in the lecture hall or the auditorium. That'll get them to come.
Free food has an amazing power of persuasion.
So these were some of the results which we were seeing from the micro radios within the site survey. So as you can see, the path which we've taken, we've looked at covering every part of the floor and being pedantic with our site survey, taking it slow, not rushing. If we have to do it again, we'll do it again. If we have to do it 50 times, we'll do it 50 times until we get it right. So if you take the initiative at the start, I believe you can get the correct result. So just be pedantic with your site surveys. As you can see, the micro radio is spreading out. This area here is not with the attenuation. This area actually is. So FRA done a fantastic job, and RRM and gym settings, which he helped me with, obviously achieve the result which we needed.
So to confirm, these are installed under the desk, and then is the I guess, how is the AP mounted? Is it just attached and facing the floor then, or how does that?
Just basically up on the floor, and safeguarded, with cable ties on each side, and it's in an area which can't be moved, and it's obviously not a trip hazard for students. So we had a lot of concern with that.
Yeah. And then you're taking these measurements basically at the same kind of height of where they're going to have their computers on the desk?
Correct. Where we used, that little feature which Ekahau has under the options tab, where we visualize it at 1 meter or 1.1 meters or 9. I think the actual measurement was 900 mil. So it's a really good feature to have, and to be able to see that in real time and get close to our predictive results was absolutely astounding.
Yes, looks pretty close to what you were showing us before on the predictive. Obviously you're going to have little nuances that are going to be not perfect in the predictive model, but the goal is to get you as close as possible to at least get the right number of APs and the optimal location of those APs.
Yeah, exactly. When we tried to mitigate having access points too far to the right here, where it was an open area where the access points would see each other. So we actually had to hide these ones under the side, under the desks, and just keep the coverage, the microcell coverage, to a minimum. Obviously, the macro would be bleeding out a lot further, but with the attenuation, that's why we require attenuation within this design. Jump back into there. To the full screen. I see. Is it in full screen yet? No.
I see the PowerPoint deck right
there
now.
we are.
There it is.
Yeah,
Yep.
That's it. Cool.
Yep.
So these are some of the cool facts which we saw from the exam. And another thing to state too, that the exam was actually wired and wireless. So we did tests with both, where if wireless was to drop out, obviously due to the high risk that we had with the reputation of the university, we ran wired in conjunction with wireless, but purely obviously a wireless exam. If wireless was to have any issues, then we'd flip back to wired. And it wasn't the case where wireless was 100% reliable. These are some of the cool facts that we had from that exam. And that's actually a view of the exam hall. So we installed the Cisco 3850 switches, both hot and cold spares on standby, in I think 5 racks, 5 network racks. We had 26 Cisco 3802i access points, where we were trying to achieve a ratio of 35 to 1 clients per radio. We had 2 backup generators, 6 UPSs, we had 2.5 kilometers worth of fiber cabling, 20.5 kilometers worth of UTP for the wide exams, 150 meters of power cabling, and for OH&S purposes, 60 rubber mats. And this was all temporary. This was all to be removed after the exams were taking place.
That's pretty
Some
awesome.
of the other, yeah. So the guys and girls at Monash did a really good job in obviously making sure that everything looked fantastic and was 100% looking reputable. So we now move into the support phase, where we've got the SE Connect mode access points, which we're using Cisco 3700s, where we had 4 of these placed around the floor, and we could monitor. We had 4 separate screens set up. As the exam would take place, we could actually monitor and look at any security risks in a way where we were seeing anything like RF jammers on the floor, or any interference brought in, which would be able to pick up during initiating a spectrum analysis, and looking at the high duty cycle if there was duty cycle spikes. This is old school method of doing it, but I still feel that it's a fantastic way to test and monitor.
So this allowed you to watch it real time as the testing was undergoing.
Exactly. We could watch it in real time and look at our sweep cycles and duty cycle and any layer 1 interferers in real time. So obviously we can't attend on the floor, and we can't, bring our G2, we can't bring any other, or our sidekick on the floor as an exam's taking place. So this was, really, really good to be able to see and to do. So we started celebrating at that stage where, we've got the design in place, and we've, how did we go about monitoring? So we use Splunk at the university, and, I'm a heavy Splunk user. So I know this is a big topic at the moment after the WLPC with APIs. So we're looking at how we can actually leverage off the Cisco wireless LAN controller, which is quite a static device in a way, and only produces syslog and SNMP traps. But, having someone stand there and watch the messages slide down bit by bit is a really difficult task where we've got 1 minute, 2 minutes to react to an issue. So we came up with the idea of using APIs in feeding into Cisco Prime and constantly polling the APIs and building really cool dashboards like this, where we're monitoring on the fly and be able to see, stuff like the radio resets. If there's any radio resets, if anything IEEE disconnects. This was mainly, the top section here was mainly used for the wide exams, if they were undertake, any error disables. Total wireless exam clients connected. This was during one of our stress tests. And what was the ratio of clients within a room connecting to the access points? This is one of the other dashboards which we use to monitor our environment, leading off the subject of Wi-Fi exams, which we've built where we can correlate and grab that data directly. That the data is gold at the end of the day, or they say data is the new oil, where everything that's been dropped from the wireless LAN controller, including the SNMP traps, which we can visualize in one dashboard, and a nice dashboard for an operation center, which they can have and build alerts off, where, we can see the clients per every 15 minutes connecting on the rise. We can correlate weather versus, client drops. Whether the weather, if it's raining outside, where we see a dip in clients, or if it's super hot, being summer, we'd see a massive dip in clients. All of our models of access points and any critical alarms which we were seeing directly from Cisco Prime would get fed directly into here within 1 minute, would have issues seen and an engineer attending to the issue. This is another example that we had where we're using heartbeat loss versus the building. And we're correlating against the model of access points, where a certain model of access point had a bug or had any issues with it. We could actually correlate that against whether a building was being dropped at the moment or whether it was across campus. Obviously, for purpose of privacy, I've just taken away the building names. And that's about it, really.
That's awesome. Yeah, and all those dashboards, you said you built those using it was Splunk, and then using the network monitoring API and the Cisco equipment.
Yeah. Cisco Prime has V3 APIs that are built into it, which a lot of engineers don't actually leverage off. So I was grateful to have a good friend of mine, Jules, who helped me a lot with the Splunk side of things and leverage off getting that data into Splunk and being able to see it and building off it and creating a use case where we can take away our time from engineers looking at syslogs. We had 1 or 2 engineers physically spending time watching the wireless LAN controller syslogs. It took away 20, 30 hours of 20 to 30 man hours per week. So it's unbelievable.
That's awesome. Well, we're about 5 minutes from the top of the hour, so I think let's as long as you guys are willing to stick around, we've got quite a few questions in here. If you haven't submitted your question, now is the time to do so, or at least look through the list of questions and maybe upvote the ones you're most interested in seeing the answers to. If Jim, I know you've got a busy schedule, and Nathan, I know it's early morning for you, but if you guys are willing to stick around, let's try and get through as many of these as we can here.
Yeah, I can stick around for a little bit.
Cool.
No
Appreciate
problem.
it, guys. Awesome. So yeah, the first question we got here on the top of the list from Mike is, can you detail your strategy for 2.4 gigahertz saturation and co-channel interference?
Yeah, so we obviously leveraged off using the 5 gigahertz. If we were to leverage off using 2.4, we would have to definitely turn off some radios because co-channel interference across the floor would be beyond crazy. And if we were relying on attenuation, we would need to ensure that we had 650 clients sitting down for that exam. So if there was anything less than that, we'd see the coverages bleed excessively.
So I'm curious in your process flow there, where was the decision made to kind of abandon, we'll say 2.4 and go with the dual 5? You obviously had your gathering requirements, your planning, your design. What part of that, what phase was that decided?
Yeah, look, it was decided within the design phase where we were looking at achieving, we looked at things like airtime utilization, which we also used within Ekahau to determine that, and other things which we tested on site. And due to experience, we knew that 2.4 would be bleeding, especially requiring the attenuation. So we decided, we got together as a team and discussed it and said, you think 2.4 is going to be liable? We were grateful that we were using the same client device where, it was a brand new 2018 laptop, HP laptop, and we had MacBook Pros. So that was another thing which we were able to leverage off, having 802.11ac capable devices. Why go with 2.4?
Right.
Well, the other thing that you'll find too is if your design strategy is predominantly 5 gigahertz, and keep in mind, since the iPhone 4, there hasn't been an iPhone release that is singly 2.4 gigahertz, right? So if you design properly and you get clients connected on 5 gigahertz, which there's several strategies for, 2.4 gigahertz can actually be quite usable in a high dense environment because you just have far fewer clients there.
Very good.
Yeah, exactly.
Yep. Joel, you've been keeping an eye on chat and questions. Anything stand out to you?
Yeah, I'm just going to go with the next most upvoted question. And there was a little bit of discussion about this in the chat earlier in regards to the money side of this whole thing. Ryan asks, what was the capital allocation in regards to funding for this project? And I think probably to add to that, I think there was some shock and awe earlier when it was revealed that this was like totally a temporary thing. So any comments around that?
Look, I obviously for the business side of things, I can't comment too much on costs, and I'm not allowed to, unravel the costs. So I can't talk too much about that in another way.
Yeah, I figured.
Yeah, it's quite it's quite crazy to think that it all is temporary, and to see the workmanship that was involved within this was just unbelievable. It even blew me away. And we've seen stadium designs, we've seen large race courses and crazy designs. And this just blew me away, considering that it's all temporary. Normally the solutions which we always do are permanent solutions. So, yeah, I can't elaborate too much, unfortunately.
If it's mission critical, though, it's got to be done, and it's got to be done right. And I noticed some things like redundancy, like 2 backup generators,
Yeah, exactly. And we're going through some quite hot days where we had one of the backup generators on air conditioning. On the air conditioning unit. So we obviously have to ensure that the students are comfortable in their environment and better strategy around that and to achieve the results which we needed. So it's interesting.
So this one is the next question here from Max has a few upvotes on there around RxSop. Were you guys using RxSop at all with the, did you tweak any of those knobs as part of this deployment?
Yeah, look, we're looking at it. RxSop acts like as earmuffs for the access point. So it's one of them things which it's quite risky where it can affect, and I'm sure Jim can discuss it. I'm not an expert on RxSop, but it's one of them things where...
That's what I was going to say. Maybe that's a good place to start thinking, a lot of our audience probably doesn't know. That's to my knowledge, that's a specific Cisco thing, right? Jim, you want to shed some light on RxSop?
I can, yeah. RxSop is receive startup packet threshold, and it's right to be cautious with that. fear is understandable, particularly in an unknown environment. Generally speaking, the settings that are available on the GUI are fairly tame by design. But what RxSOP will do is it will limit the hearing radius of the radio itself by setting a threshold that a packet then becomes a packet for my counters, right? So there's all kinds of, the CW, the nav, all kinds of timers that when the AP hears it, it sets that against its TX opportunity timer in a very high density environment where, your operating level is much above where CCA normally is. It'll preserve channel utilization or the count, and it'll allow the AP to transmit sooner. Does that make sense?
Yeah, makes sense to me.
That was a slow yes.
I was muted. I swear.
Okay.
So here's another question. Good question from Richard that's received some upvotes. And I think this is a really good one. Is the exam delivered internally or from an external location, like an LMS vendor in the cloud, for example? And where did the uplinks and downlinks become critical in your plan?
So once again, I can't leverage too much onto that question, but from what I believe, it was an external exam, and we used a safe exam browser to obviously ensure that there was security around that, and we had programmers and devs obviously meddling with the code to ensure that it was 100% reliable and secure. The uplinks, yeah, we had dual uplinks on our switches or our routers leading back, with obviously UPSs attached, and everything was just basically secondary. We had to think of everything all the way up until our border routers. So it was 100% reliable that if something did occur, or if there was an outage, it'd be resilient.
Awesome. Yeah, I think somewhat related to kind of the restricted access security thing. Did you restrict access to the test AP so only the provided exam laptops could connect? The other part of that was, else did you see student iPhones and other devices connecting as well?
iPhones and other devices were not allowed within the exam hall, so it was quite restricted where students would have to leave their iPhones and other smartphones outside the exam hall, or it would be an instant fail. So it was quite enforced. Obviously exam conditions, it's quite looked upon, and we ensured that anything, even smartwatches, taken away. We weren't allowed to obviously have anything within there other than you sitting down with a laptop. What was the first part to that question, Jerry?
Yeah, just basically, was it the SSID? Was it locked down, or was it an open?
Yeah.
Did you have like a guest SSID, or EDU roam or anything like that?
Yeah, so we were looking at EduRoam and other things, and once again, I can't comment too much on this, but we did lock down the SSID, and we ensured that it was 100% safe and secure, and we weren't going to get bleed if we were to use EduRoam, which we were thinking of, would be getting bleed from other access points outdoors, where the clients might be connecting to outdoor access points or which are around the vicinity. So we didn't want to, we use RF profiles and stuff and AP groups, which obviously assisted in that.
Yeah, you can enhance that also. You also used directional antennas around the side, so you had backload protected and prevented more leakage to the outside. Higher data rates, the thickness of the walls, you can isolate it.
Yeah, exactly. So yeah, we ensured that we went with a separate SSID.
So I'm just going down the line of upvoted questions here. So this is just the next one. It's a question from Mohammed. Is there a reason why 3802s and not 2802s were used for the APs?
We had them in stock. That was purely simple. We just had them in stock. And generally, we don't deploy 2800s across campus. It's generally a standard where we deploy 3800s. So yeah, there wasn't anything really specific around that.
It makes sense. No reason to order a model number down when you have them sitting there already. So
exactly.
Looks like the next one we got here is actually a little, a little different topic here around Android. Either of you guys, Jim or Nathan, you guys Android users?
Yes, yeah.
So maybe you can shed some light on this because I am not typically an Android user. Joel, I know you are as well, but yeah, issues about using Android and Android apps for doing some basic Wi-Fi
Yeah.
analysis, specifically talking about Wi-Fi Analyzer, and with Android Pie specifically, the latest Android version, kind of crippling the Wi-Fi tools functionality and very slow updates to its scanning.
Yeah, I've seen that, and it's quite an issue at the moment. I know that for the Wi-Fi analyzer, you need your location turned on, obviously with your Wi-Fi turned on, and the scan rate is a lot slower to what we used to see. So that's all I know from that standpoint. I'm not a specific Android geek in a way. I don't know too much about it, but that's what I've seen on site. Joel can probably shed more light.
A little tiny bit. I do agree, Nathan. I do know that you have to have, like, basically the GPS option. You have to have that turned on for Wi-Fi scanning to work in Android. They are just plain tied together. That's just how it is. As far as using Wi-Fi scanners and things on Android, to be honest, even though I am an Android user, I really don't fire up Wi-Fi scanners on Android as much as I used to. I usually here's a plug for Ekahau. I usually fire up Ekahau with the Sidekick because I just want to get the full spectrum, or I use Wi-Fi Explorer on my MacBook. I've kind of gotten away from using my phone for any kind of troubleshooting work.
Just curious as an add-on to that too, because we typically just use a power pad, right? Say 10 dB in a extremely dense, high density environment. And that's designed to catch, because the last time we did testing across all the clients, which is an exhaustive process, we found up to like a 13 dB sensitivity delta between the best and the worst. And it didn't matter whether it was Android, or an Apple product. It's really implementation specific to the device and the radio choices. So it can, even if you do test with a phone, there's no guarantee that this is actually going to be replicable even on another phone of the same model. So do you guys also just kind of add that in and say, hey, build a safety margin and let it rip?
Yeah, factoring in the device capabilities, you're saying?
Yeah, or when you're doing the design, the desired power level at the floor, you can offset that for what you expect the attenuation of the devices to be. But doing that for every device, particularly when you don't have a control over what devices are going to be in the environment, do you just apply that as a 5 or an 8 or a 10 dB, delta that you expect to see when the room is full with, unknown devices?
Yeah, Nathan, I think, using the RSSI compared side of things, you can get at least like an average, right, of kind of, some numbers to factor in. So yeah, for like a BYOD environment, if you don't have that one particular least capable, most critical device, maybe using some type of a summary is what I probably see most commonly of, okay, well, we know there's going to be a lot of mobile phones or a lot of tablets or something that we're going to need to support. What are those? Yeah, what are those device characteristics? What are their antenna characteristics like? Are they 2 spatial stream, 1 spatial stream? And then, what are their max transmit powers? What are their receive sensitivities in comparison to my measurement device? And then factoring all that in the design and validation.
From the kind of the perspective of, the iPhone versus Android thing, to me, it seems like iPhone is fairly easy because there's just a handful of models, whereas Android, it's just the wild, wild west. I remember back in the day when there was like 2 Android phones out there. You had like the HTC Dream and you had I don't know, I forget what the other ones were, but there are thousands and thousands of variants out there now. And so I have no idea how to look at Android devices and decide what you're going to design a network to achieve from a device support standpoint.
Well, cool. I see we're about 10 minutes past the hour here already, and I want to be mindful of our guests' time here. Me and Joel, we don't have anything to do the rest of the day, I'm sure, but I'm sure our guests here have some other things to do. And I think, Nathan, it's about 4 a.m. your time. Is that right?
Probably like to go to bed.
Just hit 5 a.m. and I've got to be at
5
work in
a.m.?
3 hours.
Oh boy. All right. Well, I will definitely wrap things up then for that reason alone. And yeah, I just want to, obviously you've got some special thanks here. Anything you want to specifically call out here before we wrap things up?
Yeah, obviously, yeah, sorry. Yeah, special thanks to everyone at Monash. Firstly, that helped, all the managers, directors, engineers, on-site support, exam people, adjudicators. They obviously made this all possible. A special thanks to my colleagues, Tristan, Gia, and Neil, who obviously helped and assisted in this design. Special thanks to Jim Floric. Floric, champion. Yeah, obviously helped us out. Thanks, buddy.
It was entirely my pleasure, Nathan. It really was.
Yeah, it helped us out immensely with this. So thank you very much. And obviously to Ekahau guys going back and forth with the support. Thanks, guys. Much appreciated. And yeah, just a shout out to some of the Oz Wi-Fi guys, Wi-Fi Bonds, WasFi, the WLAN and Mr. CCIE. And if you want to know more, or you want to understand a little bit more about this project, feel free to hit me up on Twitter. Happy to answer any questions. And yeah, and then we'll go from there till next project.
Yeah, thank you guys very much. This has been awesome. I learned a lot through this, and I hope our attendees did as well. Thanks everybody for jumping on and listening, and for all the questions and comments and everything along the way. That's why we keep doing these.
Yeah, thank you very much. Thanks, everyone.
All right, thanks, guys.
Thanks for bringing it together.
Yeah, absolutely. Thanks for being on.
Thanks, guys. See you next time.
Thanks. See ya.
Yep.
See ya.